All right, cool. So I'll start with it closed. This is going to be our sheep heart. Um, just quick, a lot of the vessels on the top are usually obscured in a lot of this fat and adipose tissue. But one that is usually very identifiable, and actually I'll use this sheep heart for that, is going to be this pulmonary trunk. This usually tends to be very characteristic and going at a very cross angle across the heart. And this also tells you where the front of the heart is. So if you see this like nice big vein, this is an artery. This is coming out. You see this nice big artery coming across, then it is the front of the heart. So you can see these are the auricles on the outside. So the auricles are basically extensions of the two atria. You don't need to know left and right just looking at it this way, because again, like there's a lot of adipose tissue here, so that's it's just a level of difficulty that you're not expected to have at this point in the course. I'll do one final blood vessel. So that's the pulmonary trunk or pulmonary artery. Then this is the aorta. So actually the arch itself is obscured by all this fatty tissue, but this would be that first branch, so the brachiocephalic trunk coming out of the aorta. And you can tell it's the aorta because it's going to have the thickest walls of any of them. So I think that's pretty much coronary sinus. That's the other one. So that's going to be like basically sitting right in here between the fatty tissue over the auricle and the fatty tissue around the ventricles of the heart.
Is that on the back side or the front side of the heart?
The front coronary sinus will sit on the back. All right. There's also, and again, condition of the heart really depends if you can see this or not, but these are going to be your interventricular grooves here. So this is basically on the outside where that interventricular septum is going to lie. On the inside, here we've got our interventricular septum. It is, as the name implies, the septum or the divider between the two ventricles. Interventricular. And now that we've got this heart opened up, your left side is going to be the one that has the nice thickest walls. So this left ventricle, this is going to be the largest chamber of the heart because it needs to pump the blood out of the aorta and to all of the rest of the body, so it really needs a lot of that muscular pressure behind it. Then the right ventricle is going to be on the other side. And you can see if we look at it from this direction, again, look for those nice thick walls. So looking at it from this direction, then this is the left side of the heart, and this is the right. Quick note about the different layers of the heart. This outer layer is the epicardium or pericardium, sometimes it's called that as well. Then the inner muscular layer, this is the myocardium. Myo meaning the muscle part, and cardium, of course, heart. And then this inner layer is the endocardium. So keep in mind if you've got a pin in the structure and it says layer instead of structure, what I want is, like if the pin's here, I don't want the interventricular septum, I want the myocardium if I'm asking for the layer. If the pin's here and it says structure, then I want the interventricular septum. And if you have any questions, like feel free to ask. Like the worst thing I can do in an exam is just say, I'm sorry, I cannot answer that question. All right, so there's the layers. Let's go back to the chambers. So you've got your left and right ventricle here. And then above those are the left and right atria. Atria is just plural, so left atrium and right atrium. Sorry, right atrium. Then you can see in the ventricles those valves really clearly. So here on the left side we have our bicuspid, not tricuspid valve. This is also sometimes called the mitral valve because it looks. I have never been able to see it, but some people say it looks like the mitre of a bishop, so that's why it's called the mitral valve. I guess it's open to interpretation. But connecting those valves, you can see all these fibers. These are your chordae tendineae. So I've got them underneath the probe, and these are going to connect the valves with the papillary muscles inside the heart. So this is not a structural muscle, meaning these muscles don't look any different than the other parts of the heart under a microscope, but they connect to these chordae tendineae, and that's why they have that special name. So like all of these bumps where the chordae tendineae attach, those are all the papillary muscles. And you can see something similar on the right side. You can see it more clearly on this side of the heart. So we've got our chamber is the right ventricle here, and you can see all that chordae tendineae. Now on this side, this is called the tricuspid valve. And the chordae tendineae attach that tricuspid valve to these, again, papillary muscles. So it's called the tri versus the bicuspid because these are basically like the two little leaflets that make up the valves, or rather, two in the case of the bicuspid, and then it's like three little leaflets that make it up on the tricuspid side. Some of the models, like the heart models, you can see kind of sort of, there's one that's made out of paper, and they actually took the time to like cut 3 different and then 2 different paper strips. Just do some model shopping after this to compare and contrast. Then there are 2 more important valves. So on this side, this valve coming out of the left ventricle, you stick the probe up through here. I don't think any of y'all you'll be able to get the right angle on your cameras, but if you afterward you actually like look down in here, you're gonna see like a whole bunch of half moon type structures, and that's gonna be the aortic semilunar valve, called semilunar because the structures of the valve look like little half moons. So if we stick the probe up here, you'll actually see this is going to come out of the aorta. You'll see that? And then so if the aortic semilunar valve is going to the aorta, the pulmonary semilunar valve coming out of the this one's going to be a bit tricky. So sorry. Do my best here. This one is very deep inside the right ventricle. Y'all might have to take my word on this one, but if like you had very carefully been able to get the probe all the way up in there, that's going to pass through the pulmonary semilunar valve and then come out this pulmonary trunk here. Where's the opening to the trunk? Let's see if I can. Yeah, no, I don't think that angle is quite right. That basically has to like break the probe in half to come out the other side. See if it's on this one. Well, these hearts are being very stubborn. I'd suggest you just look at it on the models. But yeah, if you follow that pulmonary trunk down, you'd see the pulmonary semilunar valve down there. Let's see, I think that should be everything that's on your list. Do y'all know if I missed? Was anyone keeping track? Coronary sinus, yeah. So that's going to be on the back side of the heart. So if you find the pulmonary trunk here, the coronary sinus is basically a blood vessel that sits in between the ventricles and the atria. So it just sits in here.
In the back, right?
Yes, it's on the back side.
So the pulmonary trunk lies in the front.
Yes, pulmonary trunk is on the front or the anterior. So this is in a heart facing that way. Yeah.
Oh,
Like we're performing a xenotransplant here at Sheep Heart in a human body.